Hello everyone, welcome back to TekkinLife, and today we will be learning about the multiplication law. So, let's get into it. Before we begin with exponents, let's understand this quick little concept. So, we need to understand how exponents are constructed. So, over here we have a to the power of n. Now this means a is known as the base, n is known as the exponent, and the whole thing together, a to the power of n, is known as a power. And to clarify what this actually would mean, this basically means a is multiplied n number of times. So let's say a was 3 and n was 2, that means 3 would be multiplied by itself twice. Let's see a little example. Here's a quick little example. So we have 3 to the power of 4. 3 to the power of 4 basically means 3 multiplied by itself 4 times. So basically it means the base is multiplied by itself as many times that the exponent says. So 3 is multiplied by itself 4 times. 3 times 3 times 3 times 3. And that just evaluates to 81. Now sometimes the base can actually be a variable, such as it is here. The base is what the exponent is acting directly on. The exponent is right here and it's acting directly on the x. So that means this could also have what we call a coefficient, which is just a number behind it as well, 4x squared. Now, we must remember, when two powers with the same base are being multiplied, this is multiplication law. So, we start by multiplying all the coefficients, keeping the base the same, and adding the exponents. In our little power example here, 4x squared, 4 is our coefficient, the base is x, and the exponent is 2. Yet when two powers are being multiplied, there's going to be multiple coefficients and multiple exponents. And there may even be multiple bases, which we will see how to deal with later. Now here's a little example of multiplication law. So we have x to the power of 4 multiplied by x to the power of 3. Now, just to clarify, these brackets mean that this is being multiplied by this. So the multiplication law applies over here. It states that when two powers with the same base are being multiplied, keep the base the same and add the exponents. So right here we can see x is our base on both of these powers, as the exponent is acting directly on them, and they are being multiplied. So we keep the base the same, and we add the exponents. So this becomes x, because we keep the base the same, and you add the exponents. So 4 plus 3. And simplified, this becomes x to the power of 7. Now here's a little example of the multiplication law with coefficients. So these are our coefficients, 2 and 3. Because they come before the variable base. The base is x because the exponent, which is up here, acts directly on them. So, in this case, when we have coefficients, we need to multiply the coefficients, which is what we did down here. 2 brackets 3, which is being multiplied, and that leaves us with 6 right here. And then we keep the base the same. We know the base is x, so we kept x the same as it is in the end, and we added the exponents. 3 plus 2. 3 plus 2 is 5, and therefore 2x to the power of 3 times 3x to the power of 2 equals 6x to the power of 5. Here is one more example. 2y times negative 3y to the power of 7 times 4y to the power of negative 2. So, we start by multiplying our coefficients. 2 times negative 3 times 4. 2 times negative 3 times 4 is written right here. We keep the base the same, and we add our exponents. Now you must notice that I put a 1 as the first exponent. I put the 7 as the second, and negative 2 as the third. Now why did I put 1 as the first exponent? There's no exponent shown on the first variable of y. That's because when there's no exponent on a number, that basically means it is to the exponent of 1. So we must keep the 1 there, as it does make a difference. Now, we multiply the coefficients together, keep the base the same, and add our exponents. Our simplified version of this is negative 24, as 2 times negative 3 times 4 is negative 24, y, as that's our base, which we kept the same, and y to the power of 6, because 6 is what all the exponents add up to. Okay, now here is one last tricky example. Here we have 3x squared yz negative 2yx cubed z to the power of 4 times 5x to the power of negative 3 y to the power of 4z. It's very complicated, but once we get the hang of it, we'll understand how this plays out. So now we need to find our coefficients, as it says up here. Multiply all coefficients. So our coefficients are 3, negative 2, and 5. 3 times negative 2 times 5, which is in our final answer, negative 30. Let's move on to the next step. Keep the base the same. Now here we have multiple bases because there's multiple exponents being acted on different variables. So we combine the exponents of each variable individually. Let's start with x. X has an exponent of 2 in this little set right here. Then it has an exponent of 3 over here and negative 3 over here. So we're going to add them all together. X, 2 plus 3 plus negative 3, as it's written right here. Now we move on to y. As I told you, if there's no exponent written, that means the exponent is 1. So exponent of 1 plus an exponent of 1 again, since there's nothing written, plus an exponent of 4. 1 plus 1 plus 4. And for z, same thing. Z has an exponent of 1 here, 4 here, and 1 here. 1 plus 4 plus 1. And our final answer comes out to be negative 30, which comes from multiplying the coefficients, x, which is the base over here, x to the power of 2, x squared, since we added all of its exponents in all three of these powers, y to the power of 6, since we added all of its exponents, and z to the power of 6, as we added all of its exponents. So our final answer is negative 30, x squared, y to the power of 6, z to the power of 6. Thanks for watching, everyone. Please leave a like, subscribe, and leave any comments down below on any suggestions or questions you may have. And I'll see you next time.